In educational research, significant curricular updates typically yield small incremental gains in student performance. Improvements of just a fraction of a point are often documented as meaningful successes. But a recent study at Raja Prajanukroh 45 School in Thailand produced an outcome that breaks the standard curve. This chart shows the students' practical agricultural knowledge scores on a 40-point scale. Before the intervention, the mean score was 19.92. After the intervention, that mean jumped to 34.76. In statistical terms, this gap represents a Cohen's d effect size of 3.29. In education, an effect size of 0.4 is considered standard, and 0.8 is large. A 3.29 indicates that student performance moved over 3 standard deviations, an outcome rarely observed in educational literature, suggesting the intervention operated on a different scale than standard instruction. Raja Prajanukroh 45 School already had agricultural land and a functioning curriculum. Yet, prior to this study, the administration struggled to connect their classroom instruction with the technical realities of professional agriculture. The researchers achieved this statistical leap by utilizing participatory action research. This methodology positioned working, local farmers as the primary educational resource, replacing traditional classroom lectures with direct industry experience. The data suggests that securing radical improvements in student outcomes requires dissolving the traditional boundaries that separate the classroom from the local economy. To understand how this was executed, we look at the specific environment. Raja Prajanukroh 45 School is located in Kanchanaburi Province, Thailand, and serves a population of disadvantaged and minority youth under government care. The structural vehicle used here is known as the farm-to-school model. This model operates on 3 distinct pillars: the cafeteria, the classroom, and the community. The researchers applied participatory action research methodology to synchronize these isolated pillars. Instead of functioning independently, food procurement, academic instruction, and local economic activity were integrated into a single unified system aimed at sustainable development. This integration required 2 distinct phases of execution. First, a rigorous measurement of the existing systemic readiness, and second, the co-design of hyper-local educational modules. By connecting these phases, the farm-to-school model becomes a systems-oriented solution, generating simultaneous benefits for student education, farmer income, and regional economic stability. We begin with Phase 1, assessing systemic readiness. A community-integrated program of this scale relies heavily on invisible administrative frameworks. If the institutional capacity is missing, the pedagogical goals will fail. This table displays readiness metrics evaluated before the program. Under school capacity, overall readiness scored an exceptionally high 4.38 out of 5. Within that, regulations for food services scored 4.58, making it the most prepared element. This specific regulatory metric is the structural linchpin of the operation. The school requires flexible procurement policies, allowing it to purchase ingredients directly from small-scale local farmers. Without that administrative pathway, the economic integration between the cafeteria and the community collapses entirely. Beyond procurement, the school had already established a continuous management framework for its on-campus agricultural areas, providing the physical infrastructure necessary to host community-led activities. The critical insight here is that pedagogical innovation is strictly bottlenecked by administration. Achieving a high effect size out in the field is impossible unless the procurement policies in the office are aligned first. With the bureaucratic foundation secured, the study moved to Phase 2. The school formally invited local agricultural stakeholders to co-design the learning modules, effectively handing over the curriculum writing process to the community. This 5-unit matrix shows the instruction drivers. Activities were delegated to external partners. Unit 3's livestock production was assigned to the Young Smart Farmers Community Enterprise. Similarly, Unit 2's produce safety was taught by the local division of public health. The students were not reading standardized summaries of agriculture. They received professional training sourced from practicing local authorities, covering specialized tasks from preparing liquid biofertilizers to monitoring water quality. When a school decentralizes its curriculum in this manner, the syllabus transitions from a static academic document into a living reflection of the region's actual economic and technical capabilities. The pedagogical engine driving this knowledge acquisition relies on John Dewey's principle of learning by doing, where hands-on experience anchors theoretical concepts. To see this theoretical matrix executed, look at these images capturing active module implementation. Students are out of the classroom, prepping garden beds alongside local farmers, evaluating hydroponic cultivation, and studying ecosystems directly with experts. This model immerses students in the environment where the work actually happens. It allows them to absorb complex, tacit knowledge, like soil texture or the precise handling of crops, that cannot be conveyed through standard lectures. The 3.29 effect size measured in the study is the direct result of removing abstraction from the educational process. The data clearly shows that students learn faster and retain more when the daily practitioner becomes the teacher. Beyond the test scores, the data reveals a change in how these students viewed the agricultural sector, their community, and their vocational resilience. This table of documented student reflections details exactly how the program altered their perspective on rural labor. Notice the entry under Attitude Toward Farming. One student notes that acquiring this knowledge enabled them to confirm that farming is a profession and a source of income. Within this socio-economic context, that realization is crucial. The intervention corrected the long-held misconception that farming is merely low-tier manual labor. Improved test scores will open academic doors, but attitudinal shifts change lifelong economic trajectories. The highest enduring value of this program was its ability to restore professional dignity to local agriculture in the eyes of the next generation. This impact was entirely reciprocal. Examining the stakeholder reflections in Table 5, we see a local farmer state, "I am voluntarily proud to teach students." Stepping into the role of an educator altered how the farmers viewed their own position in the community. Recognizing these individuals as critical pedagogical assets elevated their social status. It validated their life's work and fostered shared community pride. The entire participatory farm-to-school architecture operates as a single, resilient feedback loop. Economic resources flow outward from the cafeteria to the community. In return, technical expertise flows from the community into the classroom. Finally, the classroom produces skilled students who flow back into the community. The mechanics are precise. Flexible institutional procurement policies fund the local agricultural sector. That sector then volunteers its technical expertise to the school, ensuring the classroom produces a highly capable next generation of professional farmers. Ultimately, sustainable rural development requires educational institutions to dismantle the borders separating them from their surroundings. By utilizing local professionals as direct pedagogical assets, communities can build an economically self-reliant and highly resilient future.